Okay, hello students. Welcome to chapter 6. Hopefully the course has been going well for you so far. Keeping up on the discussions and everything else. Let's jump into trigonometric equations 6.6.1. Okay. So in order to solve for trigonometric equations, we need to know how to undo the trig functions, and those are the inverse trig functions. So they're the inverse. They undo the trig functions. So review, find the inverse function of the following functions. So if I have f of x equaling 3x plus 1, then y is equal to 3x plus 1. If I want the inverse, what I do is I swap the x and the y value and then solve for y. And so that gives me the inverse function here. Okay, now the original function has to be something called 1-to-1, meaning that for every domain, there's a unique range value. And we can see that, this equation for A is a line. And so that is 1-to-1. So this is 3x plus 1, which would look something like this. Okay. And so for every domain value, there is a unique range value. For every unique input, there is unique output. And the way that we can see that for a function is we do something called the horizontal line test. If I take a horizontal line, like maybe my ruler here, okay, if I take a horizontal line, it would be 0 degrees, and just look at the horizontal line, no two places does the function cross that horizontal line. Okay, so very similar to the vertical line test for functionality, but we already know that it's a function because it's already solved for y, or for f of x or g of x or h of x or whatever. But this is the horizontal line test for functionality. So it just has to be 1-to-1 function. And if it's not a 1-to-1 function, then what we can do is we can restrict the domain of that function, and just say, hey, this we could find the inverse of the function, but it has to be restricted. The domain has to be restricted for just the piece that is 1-to-1. For example, so anyway, we solve this and we get the inverse, the y equaling x minus 1/3, the inverse, which we label as f to the negative 1 power x, is equal to x minus 1/3. That's the inverse function of f of x equals 3x plus 1. And again, they undo each other. If I were to plug a value in for f of x and then plug the output of that value, oops. If I were to plug the input value into f of x, and then I would plug that output value into f inverse, I would get the same value out. So if we do a composition of functions here, then the input and the input ends up being the output. Okay, so the same value. Say I plug in a 2 here, and then I get the function value, which would end up being what, 3x plus 1, which is 7. Plug that 7 in here. 7 minus 1 is 6/3, which is 2. And you can see that, yeah, they do undo each other. Whatever I start with, I would end with. Okay, with that intermediary step of, the output going into the input. Okay, one other thing that we need to talk about for the inverse is that if I take f of x and we have a certain domain and a certain range, okay, domain and range, then for f inverse of x, the domain becomes the range and the range becomes the domain. Okay, so this becomes the domain and that becomes the range. So the range and domain are flipped. for the inverse equation. Okay, so the input becomes the output becomes the input. Okay, so they're reversed. Okay, and again, this should be review from college algebra. Okay, so g of x is equal to x squared, y equals x squared. I'm gonna get rid of my, well, I won't get rid of the ruler just yet. X squared, y equals x squared. Okay, so again, flip or switch the x and the y, and we get x equals y squared. When we solve for this, we take the square root of both sides, and we get f, this should say f of x, or they're calling it f of x. I would call it g inverse of x, is equal to plus or minus radical x. That's not a function. Okay, that's two functions in one. That's radical x and negative radical x. Okay, and so this isn't a function because there's not just one value. Now, if I wanted to make it a function, if we look at b here, okay, b is the graph of this parabola. It's not a one-to-one function because it fails the horizontal line test. Everywhere on this parabola, there is two places where it crosses the horizontal line there. But if I only wanted it to be if I wanted it to pass the horizontal line test, I would only talk about the values that are from 0 to infinity. I would restrict the domain here. Okay. And therefore, when I took the inverse, okay, the inverse would look like this. Okay, then yeah, I would get the positive value here. Okay, and then that would be a function. If we restrict the domain to 0 to infinity, then we could say g inverse of x is equal to radical x. Okay, so, but we have to restrict that domain. Okay, let me get rid of the ruler. Okay, and that's exactly what we do when we talk about the inverse of the functions here. Okay, we restrict the domain. The domain here we restrict to negative pi over 2 to pi over 2. So there's no overlap, okay, on the sine function. And so when I do the inverse sine function, which looks like this, inverse sine of let me describe it like this. If we have the sine of theta, okay, equals, we'll say a y value. Okay, sine of theta is equal to y. Okay, then in order to figure out what theta is, I would take what's called either the arc sine of y, or we also label this as, we can label this as the inverse sine of y. Okay, so when we do the inverse function, we're finding, and this is the big idea here, is we're finding the angle. Okay, we're basically asking ourselves the angle we want to find. I don't know why I did that. Let's go back here. We want to find the angle whose sine is y. Okay, the angle whose sine is y. That's what this means. Okay, arc sine y is the angle whose sine is y. Maybe I'll write that out in words. The angle whose sine is y. Okay, now that angle has a restriction on what it can be. It can only be from negative pi over 2 to pi over 2. Those are the outputs. Remember, the domain in my original function, becomes my range in my inverse function. So the output here, the range, can only go from negative pi over 2 to pi over 2 for my inverse function. Okay, so I'm only allowed to let the angle go from negative pi over 2 to pi over 2, which are quadrants 4 and 1. So this can only live, okay, if you were to think about the unit circle, this can only live on the right side of the circle. It can only live in quadrants 1 and quadrants 4, okay, for the arc sign. If you have a value that is positive for y, that's going to be an angle that lives in quadrant 1. If you have a value that's negative for y, that's going to be an angle that lives in quadrant 4. Okay, so we restrict the outputs because we had to restrict the inputs on the original one. Okay. Okay. So so the way I could write this, maybe I won't write it as the range. Maybe what I'll do is I'll say, look, for arc sine, okay, theta can go from negative pi over 2 to pi over 2. I think that's a little bit better. Okay, this is what theta can be. Okay, what about cosine? Cosine, okay, cosine, if I say that the cosine of theta is equal to y, then theta is equal to arc cosine, oops, no, that was right, arc cosine of y, or what we would say arc sine, or sorry, arc cosine, or inverse cosine, sorry, inverse cosine of y. And what can theta go from? Well, theta can go from 0 to pi, according to the piece of the cosine function that I'm taking to restrict my domain here. So my range gets restricted, and so theta can only go from 0 to pi. Okay, and these are going to be very important in trying to find out the inverse values. Okay, we have to keep in mind that, you know, theta can only go between certain values. So again, if cosine was positive, it would be in quadrant 1. Okay, 0 to pi over 2. If it was negative, looking at the unit circle again, quadrant 1, everything's positive, right? So if y was positive, the angle would be in quadrant 1. If it's negative, the angle would be in quadrant 2. Okay, again, we're finding the angle. Okay, so that's why it's a little more complicated, because we're saying the angle whose cosine is y. The angle. So arc cosine, arc sine, they are functions, but they're basically angles. They walk and talk and look and think just like angles. Their behavior is just like angles. Okay, because it is an angle. Okay. Okay, what about tangent? Tangent, what is theta going from? Okay, well, if I take the inverse tangent, if I say the tangent of theta is equal to y, then theta is arc tangent or inverse tangent of y. Then what is theta going from? Well, theta is going from negative pi over 2 to pi over 2. Okay, negative pi over 2 to pi over 2. Again, because the inverse value of the domain of the original function is the inverse range of the value, and that's what I'm solving for. I'm solving for theta in this case. So that's pi over 2. Okay, cosecant. Okay, so we say that the cosecant of theta is equal to y. So theta is equal to arc cosecant of y. So theta is equal to the inverse cosecant of y. And what is it looking like? Oh, negative pi over 2 to pi over 2. We had to restrict our domain here on the original function. Therefore, we have to restrict our range, which is the angle, on our inverse function. Negative pi over 2 to pi over 2. Okay, let's continue. Secant of x. Okay, so secant of theta is equal to y. So theta is equal to what we call arc secant of, arc secant of y. And theta is equal to inverse secant of y. Arc secant, inverse secant, they mean the same thing. Okay, and so this again, because it's the cosine function that we're dealing with, because secant is 1 over cosine, then it's going to have the same domain and range as the cosine function, which is 0 to pi. So this is going to go from 0. So that's that one. Okay, what about cotangent? Looks like cotangent also goes from 0 to pi. Okay, and that's because the cotangent function where tangent is 0, because tangent is a proportion, right? Y over x, and where tangent it goes to infinity, cotangent goes to 0, and where cotangent goes to 0, tangent goes to infinity, and so it actually the asymptotes get shifted, and so this actually goes cotangent, which is x over y. Okay, this I'm gonna have one cycle which goes from 0 to pi, and then I'm gonna just deal with that one cycle. Okay, and so we're gonna say that the cotangent of theta, if that's equal to y, then theta is equal to arc cotangent of y, or theta is equal to inverse cotangent y, and theta in this case is going to go from 0 to pi. Okay. So let's do some problems with the arcs here, the inverse. Okay, inverse circular functions and trigonometric equations. Find y in each of the function. Okay, so y is basically representing theta. Okay, in this case. Okay, I know it's kind of confusing with what is y, what is x, but it's just basically y is the angle. We're saying the angle whose sine, that's what arc sine means, the angle whose sine is radical 3 over 2. So what angle has a sine value of radical 3 over 2? Well, that's 60 degrees and 120 degrees, right? That's the angle whose sine, okay, is radical 3 over 2. We could have rewritten this sine of y is equal to radical 3 over 2. So what angle will give me a sine value of radical 3 over 2? And it's these two. Now, the problem is that only one of these is valid. Because remember, what's the restriction on what arc sine can be? The restriction on arc sine is negative pi over 2 to pi over 2. So the positive values only map to the first quadrant. Okay, they only map to the first quadrant. So I can only have this guy here. Okay. So the arc sine of radical 3 over 2 is 60 degrees. It can't be, I'll keep that 120, I'll cross it out. Okay, what about this one? Y equals the inverse sine of negative 1/2. Very similar to what we just talked about. The sine of what value is equal to negative 1/2? Okay, so this is a negative value. Okay, so again, where are the sine values negative? Well, it's in quadrants 3 and 4. Okay, quadrant 3 would be sine values negative and 4 is negative. I want the sine to be 1/2. Okay, the sine value to be 1/2, but negative. Well, for arc sine, the only place that I can have that is in the, again, the first and fourth quadrant. Because of the restrictions on the range, okay, on the output of what that angle can be, I can only have the first or fourth quadrant. And because this is a negative value, it's going to be the fourth quadrant. So my reference angle for this is a 30-degree angle. Okay, and so this really, the angle would be negative 30 degrees. Okay, because I'm going down instead of up. Okay, and so if I want it to be a positive angle, I would say, well, this is, I'll add 360 degrees to that, and that becomes 330. Okay, okay, what about the arc sine of radical 2? Okay, this is kind of a trick question because is there an angle whose sine is radical 2? Well, what is radical 2? Well, radical 2 is approximately 1.41. Okay, and if we look at the sine function, okay, it can only have values between 1 and -1. And this thing is bigger than 1. So there is no arc sine. So there is no solution here since the radical 2 is greater than 1. Radical 2 is greater than 1. Therefore, there's no angle that will produce a sine of radical 2. Okay, maybe 1 over radical 2, but not radical 2. It's too big. Okay, so that's kind of a trick question. Okay, using a calculator, find y in radians if y equals the arc secant, okay, or the inverse secant of -4. Now let me show you how we set this up. Okay, because your calculator doesn't have inverse secant. It has inverse cosine, and inverse sine and inverse tangent, but it does not have inverse secant. So let's think about, well, what is this asking me? This is asking me, I want the secant of y is equal to -4. Okay. And so what is secant? Well, secant is 1 over cosine. So that's 1 over cosine y is equal to -4. Well, if I put the -4 over 1 and I flip both of these upside down, basically reciprocate both of these, I get the cosine of y is equal to -1/4. Now what can I do? Well, now I can take the inverse cosine or the arc cosine of -1/4. So y is equal to the arc cosine of -1/4. So if I want the secant, inverse secant, it really is the inverse cosine of the reciprocal. So the reciprocal of -4 is -1/4. Okay, so I'm going to plug into my calculator the reciprocal -1/4, and then I'm going to take the inverse cosine of that. Okay, and then in this little box here, that's exactly what they show is happening. It's the inverse cosine of -1/4. And you're like, well, where did they get the -1/4 from? This is how they do it. Okay, now if you want to just remember that, you know, when you take the arc, and this works for arc sine and arc cosine, arc tangent is a little bit different. But for arc sine and arc cosine, this works this way. Okay, so I'm going to go to my calculator and we're gonna do inverse cosine of 1/4. My calculator comes up. Let's try that again. Okay. Okay, so inverse cosine is second, which is the shift key, and then the cosine key. So second cosine is arc cosine, and then we're going to do that negative 1/4. And the negative is not the same as the subtraction symbol, so don't get those confused. The calculator doesn't not like it when you use the subtraction symbol for things that aren't being subtracted. The inverse cosine of negative 1/4 is approximately 1.82. 1.823. Okay, maybe I'll do just 1.82. Okay, so it's this thing here. Okay, which is, I'll just say is approximately 1.82. Okay. Now for arc tangent or arc cotangent, we end up having to add by 180. Okay, so it ends up giving an inaccurate value because of the quadrants that tangent and cotangent are allowed to be in. So so just keep that in mind. A calculator gives the inverse cotangent value, okay, of a negative number as a quadrant 4 angle. However, we can't have it as quadrant 4. Remember, it's quadrant 1 and 2. Remember, cotangent goes from 0 to pi. And so the calculator doesn't understand that, and it's going to give the answer, okay, as the value, okay, of the inverse tangent as a negative in quadrant 4. And so we need to take that cotangent value and make it into a positive, okay, in quadrant 2. Okay, so we're going to add 180 to the angle that we end up getting for arc cotangent. Okay, so just for arc cotangent. Arc tangent is fine, but arc cotangent, okay. Now, in order to find the arc cotangent of this guy, okay, we have to take the inverse, I'm sorry, the reciprocal of the tangent and then add 180. Okay, so for the very similar reasons to what we did over here. Okay, arc cotangent of this value, we'll just call that value y for right now. Well, we'll work with that. So if we say that the arc cotangent, I think they left off a C there. Maybe not. Arc cotangent of negative 0.2528. Okay, that's the same as, and we'll say that equals, I'm just going to call it theta, okay, because it is an angle. So we would say that the cotangent of theta is equal to negative 0.2528. And what's cotangent? It's 1 over tangent. Tangent theta is equal to negative 0.2528. Put that over 1, and the tangent of theta is equal to negative 1 over negative 0.2528. And then the theta is equal to the inverse tangent of negative 1. So it's still the reciprocal, 2528. However, again, this is going to give me a value because of the negative sign. If it's positive, it's fine, okay? Because all positives go to first quadrant, okay? Anything that's positive gets mapped to first quadrant. We're fine with that. But for our cotangent, okay, this is going to get mapped to the fourth quadrant. When I do it, let me show you that, okay? And then I'm going to add 180 because the cotangents in quadrant 4 are the same cotangents in quadrant 2. Okay, tangent and cotangents are the same. It's just a different angle. Okay, so we're taking the quadrant 4 angle and we're moving it. We're shifting it to quadrant 2. so that it makes sense, okay, that we get the correct angle for cotangent. Okay, and they plug that into the calculator here and they say, oh, well, what's the tangent here? Inverse tangent, we'll do that on our calculator. The inverse tangent of -1 over, I think it was 0.2528, is that right? Yes. Okay, 0.2528. And we'll do, I'll close the parentheses and we'll do equals, and see that's a negative value. What's my mode in? My mode is in radians. Let's go to degrees here. Okay, let's do this, redo this, but do it in degrees. Okay, and so that's -75 degrees. Okay, so that's a quadrant 4 angle. Okay, if I add 180, I can shift it to a quadrant 2 angle, and that's 104.187. So that's just what we have to do for cotangents. Okay, arc cotangents. Okay. So here it says evaluate each expression. Okay, we want the cosine of the inverse sine of 2/3. Okay. So what I'm going to do here is I'm going to draw a triangle, because this right here is looking for an angle. Okay, we'll call that angle theta. And it says we want the angle whose sine is 2/3. Okay, well, what's sine? Sine is opposite over hypotenuse. Opposite over hypotenuse. And so we could find the adjacent side by using Pythagorean theorem. So this is going to be 3 squared minus 2 squared, and then square root that. Okay, so this becomes the square root of 5. Again, that's 3 squared minus 2 squared, square root. If we want to find the third side, okay, given the hypotenuse, that's kind of the formula we use. Okay, again, it's just Pythagorean theorem. I'm just doing it quickly. Okay, but that's 9 minus 4, which is 5, and so that's radical 5. Okay, and then it's saying, what's the cosine of that angle? Because again, this is the cosine of angle theta, right? That's what the inverse sine is. This whole thing, inverse sine, is just the angle theta. That's it. Okay, it's an angle. So then we're going to say, well, what's the cosine of theta? And that becomes the adjacent over the hypotenuse, which is radical 5 over 3. Oh, okay. Okay, what about this guy over here? We have the inverse cotangent of -15 over 8. So here we have the inverse cotangent of a negative value. So we're going to have to keep in mind that, you know, the calculator would give me a fourth quadrant angle, but we really want a second quadrant angle. Okay, this is the scenario that we had right above it. Okay, now I'm going to draw a triangle. Okay, but this is not going to be a fourth quadrant triangle. This is going to be a second quadrant triangle, which looks like this. Second quadrant triangle looks like that. So this is the angle that I'm really looking for. So it's saying, oh, the cotangent is x over y, right? The cotangent is x over y, and that's going to be in quadrant 2 because it's negative. Well, what's negative in quadrant 2? The x or the y? Well, it's x. X is negative, so this is going to be -15, and then this is going to be a +8. Okay, because once again, cotangent, okay, cotangent of theta is equal to x over y. So that's the relationship. So the angle whose cotangent is -15 over 8, that's the triangle we're getting. And we want to find the hypotenuse this time. Well, that's actually pretty easy. We just Pythagorean theorem this, and this is 8 squared. Let me move it over here. 8 squared plus -15 squared is equal to, we'll call that c squared. Okay, this is 64 plus 225 is equal to c squared. And this is a very famous Pythagorean triple. This is 289 is equal to c squared. Take the square root of both sides, and c is equal to 17. Okay, it's really plus or minus 17. However, the hypotenuse is always positive, and so we can just call it 17. Okay, so this is 17. Now, what's the secant of that angle? What angle? This angle. This whole thing is theta. Okay, this whole thing is just theta. So what's the angle of, that's secant of theta? Okay, what's secant? Secant is 1 over cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. Oh, okay, that's right. So secant is hypotenuse over adjacent. That's 17 over negative 15. So the secant of theta is equal to 17 over negative 15. Okay. Okay. And you could verify these on a calculator if you wanted to. Okay, evaluate the expression without a calculator here. Okay, interesting. We want an angle, okay, with this thing. Okay, so I'm actually gonna call this angle A, and I'm gonna call this angle B. Okay, so we're really getting the sine of A minus B. Ah, I know what that is. That's a difference formula. Okay, and that is equal to the sine of A times the cosine of B minus the cosine of A times the sine of B. Okay, we learned that before. Okay, in the previous chapter. Nice, nice, nice. Okay, so now what do we need to do? We need to figure out, well, what's the sine of A and the cosine of A and the sine of B and the cosine of B? Okay, so if the arctangent of 4/3 is A, if A is equal to the arctangent of 4/3, then the tangent of A is equal to 4/3. Okay, and this is a Pythagorean triple. This is a 3, 4, 5 right triangle. If I let theta be there, then the tangent is opposite over adjacent, and that's a 3, 4, 5 right triangle. Okay. Okay, so now I know, well, what's cosine of A? The cosine of A is equal to 3 over 5. And what's the sine of A? The sine of A is equal to 4 over 5. Oh, okay. Okay, what about the other angle B? So if B is equal to the arc cosine, okay, the inverse cosine of 12 over 13, okay, then that tells me that the cosine of B is equal to 12 over 13. And so this is adjacent over hypotenuse, adjacent over hypotenuse. And again, this is a Pythagorean triple. This is a 12, 5, 13 Pythagorean triple. We've seen this before. Okay, if you want to quickly, convince yourself of that, you can square 12, square 5, and square 13, and you do see that makes sense. Okay, 12 squared plus 5 squared equals 13 squared. Okay. Okay, so we know the cosine of B is equal to 12 over 13. Okay, what about the sine of B? Okay, the sine of B would have to be 5 over 13. Do we need the tangent? No, we don't need a tangent because it's not in the formula that we have above here. Okay, this is the formula that we're plugging into. So let's plug into that formula, and we're going to get this to be equal to, okay, the sine of A. Okay, well, what's the sine of A? 4/5 times the cosine of B, which is 12/13, minus the cosine of A, which is 3/5, times the sine of B, which we found to be 5/13. Okay, so this is going to be 48 minus 15 okay, all over the common denominator of 5 times 13. What's 5 times 13? 65. So this is 65 on the bottom, common denominator. 48 minus 15 is 33. And so that becomes 33 over 65. Okay, okay. What about B here? I'm going to move this over. Let's move this over. Oops, not stretch it, move it. There we go. Let's give myself a little more room for B. Okay, so for B, I want the sine of 2 times the arc cotangent of -5. Okay, interesting. So we want to find first, what's the arc cotangent of -5? That's going to be an angle. So this, really think about this as the sine of 2 times theta. Okay, which again, I do have a formula for. That's 2 times the sine of theta cosine theta. Oh, okay. So I'm going to have to reverse engineer the arc tangent to find the sine and cosine, and then I can find out what this is. Okay, so theta is equal to the arc cotangent of -5. Therefore, the cotangent of theta is equal to -5. I'm going to put that -5 over 1. Okay, and so the cotangent again is x over y. So if I look at a triangle, x is -5, y is 1. Okay, and so if I use the Pythagorean theorem, if I square 5, that's 25. If I square 1, that's 1. If I add them together, that's 26. So that's radical 26. Okay, and this is theta. Okay, so now what do I want? Well, I want to know what's the sine of theta times the cosine of theta. Stop. Okay, so this is equal to 2 times the sine of theta. What's the sine of theta? The sine of theta is going to be 1 over radical 26 times the cosine of theta. So maybe I'll put an arrow. This is the sine of theta. This is the cosine of theta. Okay, I'm just bringing this down. Okay, and that's going to be -5 over 26 over radical 26. Okay, and so this is -10 over radical 26. Okay, now I could simplify that if I wanted to. Rationalizing, or it's not radical 26, it's radical 26 times radical 26, which is radical 26 squared. So that's going to get rid of the radical. That's nice. So this is -10 over 26, which is -5 over 13, which is interesting. Okay, because that's another Pythagorean triple. So that's kind of cool. Okay. Okay. Last 2 examples here. Write as an algebraic expression in U. So the cotangent of the secant of U. So we're going to have to draw a triangle. They're saying U is positive. That's nice. Okay, so this is an angle whose secant is U. Okay, the angle whose secant is U. I'm going to put that U over 1. Okay, so secant is U over 1. That means that the cosine of theta is 1 over U. Okay, and so let's look at that. Let's draw our angle, theta. If we take the opposite, or sorry, the adjacent over the hypotenuse, I get 1U. And so we really want the opposite side. How are we going to find the opposite side? Pythagorean theorem. Yeah, we're going to find the Pythagorean theorem there. So a squared plus b squared equals c squared. 1 squared plus b squared is equal to u squared. 1 squared is 1, so I could just subtract 1 from both sides. B squared is equal to u squared minus 1. Okay, and then we would get b is equal to square root both sides plus or minus the square root of u squared minus 1. Okay, so that's that guy. The angle, okay, let's see if this u is positive, right? U is positive. They're telling me that u is positive. So if u is a positive value, that means that if I took the cosine of an angle and got a positive value, that would only be able to live in quadrants 1 and 4. Okay, however, the restriction on arc secant is that it's quadrants 1 and 2. Okay, this goes from 0 to pi. Okay, and so if it's positive, then I'm just going to restrict myself to quadrant 1. So it's just quadrant 1, and so I can drop the negative here. I can say that b is positive square root. Okay, I can drop the negative because u had to be greater than 0. If u is positive, then it's just going to reference back to quadrant 1. Okay, the cosines and the secants are going to reference back to quadrant 1, which is nice. And so we can say that this guy, if I look at my triangle, maybe I'll bring my triangle down. Okay, remove my triangle. Okay, so he's right there now. Okay, and so what did we find? We found that this guy lives in quadrant 1, and we have the square root of u squared minus 1 as its second leg there. Okay, and so what is the secant? The secant is, sorry, what's the cotangent of theta? The cotangent is the x over y, and so this is going to be, okay, the cotangent here is going to be equal to, cotangent, we'll call this cotangent theta, is going to be equal to 1 over the square root of u squared minus 1. Okay, and I'm not going to rationalize the denominator on that. Okay, it'll be cleaner if I don't. So we get that. Okay, what about the last problem here? We have the sine of 2 inverse cosine. Again, u is greater than 0, so inverse cosines are going to be in first quadrant, so we don't have to worry about the sign there. Okay, we're going to be first quadrant, but when we multiply it by 2, we may no longer be first quadrant. So that's kind of the interesting part there. This is again sine of 2 theta, right? 2 theta. Okay, what's the sine of 2 theta? Well, that's 2 times the sine of theta cosine theta. Okay, so that's good. Okay, and the sine of theta and the cosine theta, they are quadrant 1. Okay, because theta is going to live in quadrant 1. Okay, theta, 2 theta may not, but theta will live in quadrant 1, so that's nice. Okay. So what is theta? Theta is equal to the inverse cosine of u. So the cosine of theta is equal to u. I'm going to put that u over 1. Okay, and so this is adjacent over hypotenuse. Adjacent over hypotenuse. And so the adjacent is u and the hypotenuse is 1. So very similar to what we had before, but now the hypotenuse is 1 and the adjacent side is u. Okay, so if I do Pythagorean theorem on this, okay, a squared, I'm going to run the same problem that I had before. Okay, let's do it down here. A squared plus b squared equals c squared. We get u squared plus b squared is equal to 1 squared. 1 squared is just 1. I'm going to subtract u squared from both sides. So this is b squared is equal to 1 minus u squared. I'm going to square root. And again, since this is first quadrant, this becomes positive. So this is square root 1 minus u squared. So that's the square root of 1 minus u squared. Okay. So now they're saying, well, what's the sine of that theta, the sine is going to be the opposite over the, it's the sine of 2 theta, I'm sorry. So it's the sine of 2 thetas, okay, is 2 times the sine of theta times the cosine of theta, okay. So this is equal to 2 times, what's the sine of theta? Well, let's just find sine of theta first. The sine of theta is going to be this guy here over this guy here, which is just the square root of u minus 1 squared over 1, which is just the square root of 1 minus u squared. I think I said that backwards, but I wrote it correctly. Okay, this is the square root of 1 minus u squared. Okay, so now that's the sine. We already know what the cosine is. It's right here. It's u over 1, okay, or just u. Okay, that's the cosine. So the sine of 2 theta is equal to 2 times the sine of theta, which is the square root of 1 minus u squared, times u. Okay, so this is equal to 2u times the square root of 1 minus u squared. And that's it. Okay, that's the sine of that value, okay, of that angle theta that we figured out. Okay. Okay, that's it for 6.1. I'll see you in the next section.